Welcome, everyone. Welcome to the ioGAS 8.3 webinar. I will be your facilitator for today's webinar. My name is Putra Sadikin. I'm the product manager for ioGAS. And joining me on this call is Sophie Alexander. She is in the chat, monitoring the questions and things like that. So I see that we got a few people joining us already. It's really nice to see people from all around the world. We got someone in Peru in the chat and someone from Canada. And I don't know if we have some Australians in the chat, but I'm coming over to you from Melbourne, Australia on the East Coast. So early morning my time. So what are we going to go through in today's presentation on ioGAS 8.3 is a bit on what's in this version. So this version came out last week, and we're going to go through just a bit of what is in 8.3 and also give you a demo, a live demo of some of these new features. Okay, so let's get started. So ioGAS 8.3 is a continuation of the work that we did on 8.2, largely on the drill hole module that we've added in the last release. So if you attended the webinar for 8.2 and if you've been using 8.2 so far, you know that drill hole module is one of the biggest things that we've added to ioGAS in the past few years. And 8.3 just improves on that a bit more by adding the ability to display color attribute strip log. So you can think of this as the old strip log that we had before ioGAS 8.2, but we made it much more customizable, and it just looks so much better now. So I'll run through that in a minute during the demo. And with the drill hole module, we've also added abilities to plot structural data down the hole. So previously you can plot numeric data down the hole. You can plot your dip and dip direction down the hole from your structural readings, but we've now added tadpole and scat plots into ioGAS. And a scat plot really is a way for you to visualize the orientation of your structural reading and visualizing it sort of in a really intuitive way that allows you to visualize your data in that drill hole space. So that's the same thing with the tadpole plot as well. We've also added the ability to composite your point data with an interval data table. So if you start with structural data, which is usually in points, in a points table, or something like a portable XRF data, which is usually in a points format, you measure a PXRF data down the hole, that sort of thing. You can merge that with an assay interval or lithology interval table, right? So previously you couldn't do that in ioGAS. So we've added interval joining in previous version of ioGAS. So in 8.2, we've added the ability to merge files of different intervals. So say if you have assay data every meter, and then your lithology is every 10 meters or something like that, you can merge those two tables together. But now, if you start with a point table, you can merge an interval tables into that points table and vice versa. And also the biggest other thing that we've added in this release is the Python script launcher. So this allows you to run Python scripts from within ioGAS, but also trigger a Python script if you don't have any files open, trigger a Python script to bring a file from outside of ioGAS into the program. So I'll run through a few demos of this in a bit as well. And I'll just briefly touch on a couple of these things, but it will make more sense as I go into the demo. But probably the most important thing on this screen is the single installation launcher. So previously, when people try to bring in their data into ioGAS, if they're bringing in a data set which has hundreds of thousands of rows into the program, ioGAS sometimes doesn't let you do that because of the memory limitation in the default installation that we had in ioGAS. Well, that limitation is gone, and simply it's because we now only have a single installation launcher that scales its memory usage depending on what your computer has. And aside from that, we've also added the ability to we've improved the ability to export plots out of ioGAS, and I'll show you through a couple of examples of this. And another big thing that we've added is it's a pretty major change to the attribute manager. It's just the way that we can now attribute polygons rapidly in ioGAS. And again, this is one of those things that's much more easier to show rather than tell. Okay, so I'll start with just a few screenshots, and then I'll jump straight to the demo. But what I was saying earlier, we have tadpole and scat plot now in ioGAS. So over on the left, that where my mouse is, that is the tadpole plot. So the line in here, the direction of the arrow or the line indicates the orientation of that structural reading, and then the distance along the x-axis, that's the dip angle for that structural feature. And the scat plot separates these out into two plots, and this is quite a unique plot, as you can see in here. So in the middle, it's 0, but then it goes through all angles. So you go from 0 in the middle, 180 on the right, and then 360 on the left. So it's kind of like it's a really neat way of displaying your dip direction and dip reading. All right, so we now have the color attribute strip log, and the color attribute strip log is really it's something that we've already done before in the past, but we didn't have it in 8.2, just with the programming limitation that we had in 8.2, but we've managed to figure it out in 8.3, which means that when you change things in the attribute manager, you can now see it attribute live in a strip log that automatically updates live whenever changes are made to the color groups. And again, this is one of those things that works better if I show it in a demo. So Nick, I'll answer your question in a bit once I go through the demo, unless Sophie can answer it in the chat. Okay, so multi-trace stack strip log. So this is probably one of those things that people don't really use in the past version in 8.2. But in 8.2, people usually use the multi-trace stack strip log for something like AI Cyrus data. So spectral contribution. When you see it down the hole, you can see the spectral contribution for each of your sewer minerals, for example. That's the most popular use of this tool, but most people don't know that you can actually use it on geochem data, right? So you plot your assay data down the hole, and you can see the changes in the representation just across the hole. But if your data is in a different unit, then you'll end up with something that's a bit silly because if you're plotting something in the low tens or dozens, and then you have something in the hundreds or thousands, then when you put it side by side, of course, the ones in ppm, the ones in thousands or hundreds will dominate the ones with a lower magnitude, so lower value. So what we've ended up doing is if you select a bunch of alias columns, alias geochem columns, it will automatically convert elements to the same unit prior to displaying them on a multi-trace stack strip log. So it just makes it easier, more user-friendly for you guys to use. Right, so I've talked about this before in the past. So point data compositing, right? So instead of merging interval to interval, you can now merge point to interval and interval to points. And I'll show a demo of this in a bit. All right, so Python script launcher, there are two places so you can find it. So you're either starting with an ioGAS workspace. So if you're starting with an ioGAS workspace, what you can do is basically you can run a Python script that grabs the variables that you select. So any variables that you're selected, you can push it out to Python. Usually it's into a data frame, so Python data frame, and then you do things to the Python data frame outside of ioGAS using Python, and then push the data back into ioGAS as a new column or a new row. Anything you want really, but the most common case is running a script to generate a couple of new columns. And I'll run through a couple of examples of this in a bit in the demo. Then another use case is if you don't have any data to start off with. So if you're starting from scratch, if you don't have any data open, you can call a Python script to load a data from a certain location. So if you, for example, if you have a Python script that processes last data, for example, you can bring that into ioGAS using the Python script importer function. And that is exactly the demo that I'm going to run you through today. I have a script that allows you to process something like a last file or anything like that. So, but another common use case is when people want to run a Python script that does things like calculative mineralogy using Python. And so they run it on a database file using Python. and then spit that data back into ioGAS. So that's another way to use something like that. Cool. All right, so this is another thing that I talked about. So in previous versions of ioGAS, if you're running into issues when you're trying to bring a big data set, sometimes you run into a message that says, row limit exceeded or something like that, right? So, but in this version of ioGAS, it scales automatically to the amount of RAM you have on your computer. So, well, it sort of depends, right? It depends how much RAM you have on your computer. But if you're running like a 32 gig sort of computer, you can bring in quite a substantial amount of data, and then we actually have a way to push that even further by disabling some safeguard that allows you to bring in even larger data sets. But yeah, I'll talk to about that in a minute, as I'll show you what it looks like in the installation directory. I'll touch on this in a bit later on, but you may notice that in the previous version of ioGAS, we've changed the ways that people can export a plot out of ioGAS, and this version actually has a way for you to make your exports be more standardized. And you can record this in a workflow recorder in ioGAS, which allows you to record or standardize the way that you export certain plots, so that you can automate certain routines that you have in exporting your interps out of gas at a certain point in time. All right, so this is not a big thing that we've added. It's a bit subtle, but now you can actually attribute a polygon just by right-clicking on it on a diagram. Whereas before, you can just go to the right-hand side toolbar and you go auto attribute by polygon. But when you do that, it auto attributes to every polygon on the screen. But now you can individually attribute polygons, which makes it quite useful and more flexible. And I'll show you a workflow where that can be done. And this is not a big thing. It's what I like to call rapid attributing of data points. And really, it's when you want to attribute points in a plot. So if you think of something like a Scott Haley type workflow, where you attribute clusters of data points in a few scatter plots, how you have to create a new color group every time you do that in the attribute manager. Well, now you don't have to. Okay, so it just creates your attribute color groups automatically as you go through it, which again is just one of those things that looks better when I show it. All right, so let's jump into the live demo. So we got about 40 minutes for me to run through this. So we'll see how we go, but we'll start. All right, so just because I'm changing windows, everyone in the chat, can you see my screen actually? Yep, cool. Perfect. All right, so what I'm going to run you through now is I'll start off with a structural data set, right? So when you look at the scat and tadpole plots, these are the tools that are specific to the use of structural data. So I'm going to show you what it looks like. So we got a stereo net in here. So we got some structural features, and then I'll plot up a rows plot as well. And then I'll change the colors to your structure type. And there you go. So that's a typical stereo net. And I guess some of you have used this before, some of you have seen it. But if you have data like this, another way that you can visualize it is, of course, you want to visualize it in a spatial sense. So I'm going to select a few drill holes in here. And if you haven't attended the previous webinar, you probably haven't seen this new drill hole module, but we haven't changed it in this release. But this is probably one of the biggest things that we've added in ioGAS in the past few years, right? So I'm just going to select a few holes in here, and that will make these two icons not grayed out anymore. So you can see in the drill hole ribbon, you have a scat plot and tadpole plot. So SCAT stands for Statistical Curvature Analysis Technique plot. So let's open that. So what it displays is your dip direction and then your dip angles in two separate plots. And it functions much like any other plot in GAS. So you can zoom in and zoom out, and then you can do auto attributing things on this as well. So if you go and click on this button right here, you can turn on point attributing, and it allows you to do this sort of thing. I'm just going to create a new color group, and I'm going to select them. And what I can do is, I can do two things, right? So I can select from a cluster of structural orientations in here and see that being reflected in my scat plot. Or what I can do is I can do that selection in the scat plot itself. So like this. And then you can see those changes being reflected in the other plots within aiGAS. So you can see that being reflected in the steernet in here, which by default it uses a certain symbol and size. But if you have it set to attribute manager symbol and size, you can see it being reflected in here. So that's a scat plot. A tadpole plot, the orientation or the direction of the line in here, that's the direction, right, of the structural feature. So you can do the same thing in here as well. So you can toggle point attributing on and off. And I'm just gonna auto attribute again by structure type. And you can see that being reflected in here. So it takes in color attributes, size attributes, but also shapes as well. So the arrows or the lines, they remain consistent, but it's just the symbols that's changed. So yeah, so that's a scat and tadpole plot. And it's interactive with the attribute manager. All right, so now we have a bunch of structural data, right? So what we're gonna do now is I'm gonna show you the data view in here. So we only have a few columns, right? So we only have your dip and dip direction. So these two columns that I use on the right, those are the two columns that I use for my stereo net and my scat and tadpole plot. So we only have like 12 columns in here. So we're gonna bring in a bunch of other stuff as well. So we're gonna bring in some XRF data. Okay, so I'm gonna go to the drill hole ribbon, and I'm gonna click on this button, drill hole compositing. So when you want to join, when you want to add new columns into aiGAS, there's two ways that you can do it now. So you can use the drill hole compositing or join incoming interval or join incoming point data, or you can go to the file ribbon and use the join file. The thing about join file is that it works on a row by row basis. Okay, so you will need to have sample ID set. So it works well if you, for example, you want to add new assay columns into ioGAS that has the same sample ID. So, if you're getting data from a different lab, for example, for the same sample, then the join file function works, right? But if you want to bring in different interval, or you want to add an interval table to points data, which we have right here. So we got a points table, basically. And then you want to merge in an XRF data, and the XRF is measured on an interval basis. You want to use this drill hole compositing tool, and it works the other way around as well. All right, so I'm going to click on that tool, and it's going to ask me what file I want to open. So I have the same project, same holes, not all of the holes that I have in here, but some of the same holes. And then but this is actually XRF data. And then it's going to ask me interval join columns in new data set. So remember, we're starting off as a points table, right? And then I want to merge in an intervals table into the points in the structural table that we have in here. And so the same option that we have before, using weighted average for numeric columns, that sort of thing, still applies. So if you want to go the other way around, so if you start with an assay table, if you want to bring in incoming point data, you want to assign the same column in here in the from and to fields. All right, so I'm actually bringing in a gas file, and the gas file already has that interval tables, but you can join to gas file, text file, CSV, or Excel spreadsheet files. Okay, so as you can see from here, if you scroll down, I have about 159 columns, which is pretty standard for an XRF data. So you got your assay data, and then your error, and then your corrected value, and that sort of thing. So we'll bring that in. And then, so it comes up with a message, merge incoming intervals to existing point data. And so that's just telling you what it does, and you say yes. And then it's gonna go, yeah, compositing join. It adds these new columns, merge this many rows, and etc. Cool. And if you go into your data view, if you go all the way to the end, you see all the assay data that you have added in here. Okay, so yeah, so that's merge merge existing point stable to interval stable. While we're here, in the legend window, you now have the option of displaying row counts. So if you right click, there's an option in here to show the number of items in each group, in color, shape, and size. So it's kind of like, going to the attribute manager and looking at this number, but not having the attribute manager open at all times. So it's quite good for that. And while we're talking about importing assay data, I'm just going to show you a couple of the new provided resources that we have, because generally I tend to sometimes miss this in our webinars. But we have a new diagram by Ross Large. So a few of you have asked for this to be added into this version of aiGAS, in which we've added. So this is Ross Large PCD alteration diagram. I think the paper is in review, or it's already been published. I'm not sure, but anyway, we've added into aiGAS, and yeah, so that's what it looks like. And we've also added a bunch of niggly diagrams as well, which unfortunately I cannot open in this file because I don't have all the columns that I need. But if you remember from the last release, so Ian McDonald, he's the one who helped me make a lot of these diagrams. But the niggly diagrams are a very I think they're a very useful alternative to molar ratio diagrams for looking at rock type identification and alteration characterization and things like that. So that's just as a CQ into that provided resources update. All right, so we got a bunch of windows open in this plot. So in previous versions of aiGAS, what you may notice is that this is a list of windows that you have, but we've added a new thing in here that allows you to sort and group your plot windows. And I'll show you this later on as well with another file, which hopefully I will have more windows. But in here, you can actually now sort your list of windows here by alphabetical order, which makes it so much easier for you to find plots that you're interested in. And you can also group by plot type. Okay, so in here, this is a bit of a moot point because we only have one plot type for each plot type. So, but yeah, basically, if you have a bunch of scatter plots and things like that, find out where they are. This sorting and grouping function in the Windows list is quite useful for that. So hopefully you can see that on the top right corner is where you can access it, and you can also access it from the Windows list in most of the ribbon tabs where you can find a Windows icon, right? So yeah. All right, so while we're here, I'm gonna show you the installation folder for aiGAS. So for most people, they would have aiGAS installed in C program files, anything like that. But in my computer, I have it installed in my app data local folder, but it doesn't matter. But if you look in the installation directory for 8.3, you notice that there's only one executable file. And this executable file actually scales memory usage based on your RAM. And if you go into your help about, well, I'm doing a bit silly, something silly in here, and I'll show you why in a minute. But it basically scales based on how much RAM you have in your computer. But there's actually an option in the settings in here that allows you to ignore cell limits. So it does not restrict file size, grid size, or SPLOM size. So it's sort of like another option that you have if you want to try to bring in really large files into aiGAS, that sort of thing. So while we're here, and I'm not using a Mac version of ioGAS, but in the Mac OS, we've made a couple of pretty big changes. So if you're using a Mac version of 8.3, you will need to run a script. I don't have the screenshot in front of me, but maybe maybe I can put a screenshot in the chat later on. But there's basically a script that you need to run in order to move user files, including your license file, into the ioGAS 8.3 installation. And there's a different way of installing ioGAS on the Mac now. So to install ioGAS on the Mac, you will need to drag the app into the applications folder. And again, I'm not a Mac user, but I just thought it's important to mention that just in case there are some Mac people, which I think there are a few sort of in this chat. All right, cool. So I'll go into a bit of a detour, and I'm gonna talk about a couple of other things that we've added to the grid file, sorry, the geotiff grid importer. So if you remember from 8.3, we've added the ability to import a geotiff into ioGAS. And let me just try to remember where I have these pictures. Let's see. I should have it somewhere. I don't think I have the files for this. I'll see if I can show it in either in this demo or this afternoon's demo. But basically, if you're importing a geotiff file into ioGAS, right, you will need in previous versions of ioGAS, if you import a geotiff file, you can only import sort of one at a time. But if you've already imported multiple geotiff images into ioGAS, what you can do now is you can manage them in sort of a library of imported geotiff files. So you can sort of cycle between the different geotiffs that you've imported in a geotiff image manager. So unfortunately, we probably won't have time to show in this demo, but in my afternoon session, I'll be sure to show it. But it's basically just having it easier to select from multiple geotiffs that you've imported, and if you have multiple ones that you've already imported, you can cycle between them in the different variable maps or attribute maps that you already have. All right, so while we're here, I want to show you another thing that we've added. So some of you might already be using this selection tool, so this flash highlighter. And you can see from here that you can see that how many rows are being selected. So there's a tooltip down in the bottom that actually shows you that. So that's quite useful. Okay, so let's open up a different data set. And we're sort of within the home stretch of the demo itself today, but we'll still have a few things that I want to show you. But this will be the last file that I think I'm going to show you guys today. So we'll start with this file. So if you've attended our ioGAS training before, you probably have seen this file. So it's nothing particularly exciting. But let me just try to show you. Okay. So it's just a bunch of drill holes, and then we get some assay values there as well. So I'm going to show you sort of a workflow that we've added in this release that changes the way that we attribute data points in the attribute manager. So if, for example, you start off with an XY plot like this, right? And if you don't have any color selected, and you want to attribute things just based on clusters that you see in here, and then let's select a few other elements in here as well. And so we get a scatter plot. So every time you do that now, every time you attribute polygon, it's going to ask you, do you want to create and use a new color attribute? So it's going to create a new color attribute, and it's going to automatically select it for you. And let me do that again. It's going to keep on asking me, right? So it's a very rapid way of assigning patterns in the data based on the clusters that you see in any plot that you have in GAS. All right, so this makes things really fast, right? So that applies to attributes, to color attributes, right? So you can use this as a way of rapidly finding groupings in your data without actually having to create a new color group each time, because the previous way that we did it was we had to create a new color group, So that's sort of the old way of doing it when you had to do it sort of one at a time. Okay, and whereas now, so yeah, so that should make things quite quick or quicker than it was before. So that's the biggest changes that we have made in the attribute manager. And another thing that we've added in terms of attributing and things like that is with the attribute polygon, attribute classification polygon in a classification diagram. So say if you start off with something like this, and then if I want to open up a different diagram, right? So basically what I want to do is I want to subdivide my data um, using a combination of two different diagrams. And I'm gonna show you a couple of workflows, right? But the biggest thing that we've added is if you right click, you can now attribute color based on where the samples are plotting within each polygon. So if you right click, you'll see the name of the polygon that your mouse is sitting on, and you can auto attribute just based on that. So it allows you to do this sort of workflow. So let me just show you. So you can go like, I can see that felsic A in here is split into two polygons. So what I'm gonna do is I'm gonna turn off felsic A, and then I'm gonna try to split felsic A into basalt and rhyolite dacite. So I'm gonna turn everything off except felsic A, and then I can do that. I can do that. Well, the color is the same, but let me just change it. Something obviously different. So yeah, so look, that's sort of the workflow you can do, and you can see that felsic A has now been split into two just by doing that. So you can use a combination of the existing groups that you have, and then right-clicking on this to sort of merge your groups together. And if you have overlapping polygons, it just falls into sort of that overlapping field. I don't have a good example in here, but that's basically what you can do. And of course, if you make a mistake or anything like that, you can always undo and redo, and then you can combine attribute groups like that. If you haven't done that before, then that's another way of manipulating your color polygons. So yeah, so those are some of the bigger things that we've added in sort of that attribute manager sort of world. So now let's move on into the other big thing that we've added in the drill hole plot. So I'm gonna open up a drill hole plot. I'm just gonna select just a couple of drill holes in here. So it doesn't look too messy. So you can see there's a bar over there on the left, right? So that is what's called an attribute manager strip log, and by default it's enabled by default. And if you want to turn it off, you can just go to default preferences, and there's a checkbox in here that says show attribute manager strip log, and then you can change the size and whatever if you want to do so as well from here. But look, the attribute manager strip log, it works dynamically based on what you have in the attribute manager. So you can see that if I don't have any colors, it's all black. And let's just bring a scatter plot sort of in play. So I'm just going to show you. So, oh yeah, and you can see here in the list of open plot windows, you can see how it's sorted by, these are all my diagrams. These are all my XY plot. This is my scatter plot matrix. So, if you're one of those person who have, 50 something plots open at any given time, which, I'm one of those people. You will have you will make it you'll find this easier to have a window list that's sorted and grouped like this. All right, so I'm just going to show you quickly. So if you have a diagram like this, right? If you do this workflow from earlier, you can see as I auto attribute by that, you can see how the color changes automatically on this, and then you can see that what about that boundary in here? That looks like that's been split, but you can see that what we call basalt in here, that's actually split into two. So what can you do about that? So I can even go like this. So I'm gonna create a new group. Actually, that's a good color. And then I'm going to go and, yeah, something like that. And then just assign that into its own group automatically from here. So the variation that you cannot see, quite well from here, but you can see it in sort of the spatial plot, that variation in your SiO2 values. You can mark it on this plot, or you can, mark it in every other open plot and allow you to do that sort of workflow. All right, so while we are here, I'm going to show you the new multi-trace stacked strip log of different units. So, you have these elements in here that I have selected. Everything is in either in percent or ppm. So it's a mixed unit sort of situation. And whereas before, if you plot this multi-trace stack plot, if you have things in ppm in the hundreds or thousands, it's going to look pretty silly because the ones that you have in percent will be sort of it's going to be smaller than the ones with the larger magnitude. So what we've done is, if I select a bunch of variables, and they have to be alias, right? So they have to be alias geochem columns for aiGAS to know what unit they're in. But if you click on this button now, multi-trace stack, it will gonna ask you, not all selected alias columns are in the same units. A stack plot will be misleading, of course. Doing a unit conversion first is recommended. And it actually tells you that because it's actually gonna do it for you, right? So it's gonna convert, most of the columns that we selected are in ppm. So it's gonna convert the ones that are not in ppm into percent and vice versa. So it's gonna make everything all into be in the same unit. And there you have it. And you even have the color bar on the left in here based on the attribute manager that shows you the change in the rock type based on the changes in the geochemistry in here as well. Okay. So you can see from here, right? So you can see a bit of the variation across some elements. So that's actually magnesium, the ones in orange right there where my mouse is. And we didn't use magnesium in any of the plots that we had before. So I'm going to show you just a couple of workflows, just using things like multivariate analysis in aiGAS. So I'm going to show you a bit of that UMAP workflow, and then follow that on with what we can do in the Python module that we have in aiGAS. Right, so I'm going to select some variables that I know are multivariate, and then I'm going to run a UMAP. Okay, so I got my UMAP in here. And then, when you have a UMAP, the best way to classify the clusters that you have in your UMAP is by your own eyes, of course, because you can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have about 10 clusters in here. But there's not an easier way to finding clusters in a UMAP, and that's through clustering algorithms. So we have a thing called dbScan. It's a density-based spatial clustering. And then we also have a different clustering algorithm called HDBScan, which we don't have in aiGAS yet, but there's a Python script that's widely available for that. So what I'm going to do is I'm actually going to try to run that Python script for HDBScan as of aiGAS. So I'm going to show you what the Python script looks like, and this is where I'm going to talk about the Python thing. So I'm going to show you what the Python script looks like. So it just kind of looks like this. So what you need to have when you want to use the Python script launcher in ioGAS 8.3 is you will need to have Python installed in your computer. And there are a few packages that you need to install by default in that Python installation. So if you haven't installed Python before, then probably the easiest is to use the Windows version of Python, or you can use Anaconda or Miniconda. We recommend using something like Miniconda or Anaconda. I use Anaconda myself because it's just easier to just import the load the packages that you need. But the packages you need to run some of the demonstration script that we ship with ioGAS are things like pandas and NumPy. You don't need all of this other stuff, but I'm just going to show you. But look, the intended use for the Python script launcher is if you're already using Python in your environment, and if you're already using ioGAS at the same time, then you don't need to go outside of ioGAS to use Python. And you can sort of combine the two workflows together. And that is if you already are using Python. But if you're not, then then setting it up is pretty straightforward because you can actually tell ioGAS, you can configure where that integration is sort of sitting. So you can configure where your Python interpreter is just by configuring it in the application settings button in here. So not a lot of people use this, but and this is like the third time I show it in this session, and that's because there's a lot of stuff in here that people will find useful to have a look at. But this is where you configure your Python interpreter, and you can see here that's in Anaconda. Anyway, so a Python script launcher can be found in two places in ioGAS. If you're already starting with an ioGAS workspace, you will want to run that Python script launcher from within the workflow ribbon. And over here on the right, there's a button that's called Run Python Script with the little Python icon, of course. So you just click on that, and it navigates to your default Python directory, which will be in your app data roaming folder. We ship a few in here by default, but the script that I run in here is called run HDB scan. So I'm going to click on that, which is the script that I was showing you earlier. I'm going to click open, and it's going to take you to the Python script configure dialog. And so look, I'm not actually going to be running it on these variables. I made a mistake. I'm just going to click cancel. And I don't want to run it on my assay columns, of course. I want to run it on my UMAP columns. Okay, so what I want to do is I want to cluster this UMAP using the HDB scan algorithm. So let me go back. So I'm going to navigate back to that script. And you can see here, I've selected that script. These are the columns I've selected. And you can set it to just use multivariate rows only. So what that means is that if you're running something like a processing thing, if you want to run it through a dimension reduction technique, but you only want to use rows that have data across every column, it will force the Python script runner to run it on use multivariate rows only. And also you can set it so that you run it on visible rows only. So this is based on the attribute manager. So say if you want to run something like this HDB scan clustering algorithm on a subset of the data, you can set the subset using the attribute manager, either using your attribute color, shape, or size tab or the filter tab, and it just runs it on the visible rows. The select run function, this is based on what's configured in the Python script itself. So if I look in here, you have a bunch of parameters that you can set. So you know what your cluster size is and how many samples are within each cluster. And look, you can actually configure it in here, and then you can run the function. You can define the function that you want to run in there as well. All right, so let me just click OK, just get this running. So, okay, it's very fast. So I'm going to show you what it did, right? So when you run a Python script, it just opens up a window to the right. And then it tells you it's going to launch that script. And then it's going to move the data from ioGAS into a data frame, into a Python data frame, which is created from a JSON file. So it's ioGAS data frame, JSON file, Python data frame. Python does things to the data frame. In this case, it runs the HDB scan clustering, and it creates a new column, and then it pushes that column back into ioGAS, and that's it. Okay, so if you look in your column properties dialog, there's a new column called HDB scan cluster, and this is not a numeric column, but it's reading it as such because the cluster is numeric coded. So I'm just going to change that to text. Click OK. And then I'm going to go to Attribute Manager and color it based on my HDB scan clusters. All right, so that's a simple use of the Python script. So if I want to cluster my data, but the clustering algorithm in ioGAS doesn't do what I wanted, I can run a Python script for this to cluster it using this particular algorithm. Okay, so I'm going to run a different one. So let's go to the attribute manager. And then I'm going to just filter my data just on one hole. Just going to pick this hole. Okay. And then I'm going to plot my UMAP data down this hole, just one of the variables, which is a UMAP, right? So I'm going to plot the UMAP data down the hole. And basically what I'm trying to do is I want to try to find the differences between rows. So the thing about the Python thing in aiGAS is that it allows you to run certain functions that you wouldn't be able to run in normal sort of aiGAS circumstance. So things like, running the delta between observations. So if you look in your data like this, right, and you're trying to find a delta between rows of UMAP values. So this allows you to see between each rows, between depths, um, how similar is the value between each depth. So you're trying to find the delta between observations, and there's no way to do that using our calculations in aiGAS. You can easily find the delta between columns, but you cannot find the delta between observations. So there's another Python script that I want to run, and I'm going to show you what that looks like. So it's just it's a row difference calculation. So it's just a simple lambda row differences between rows, right? So I'm gonna run that script. And then I'm just selecting in a UMAP column. So basically I want to see how similar my UMAP column is sort of down the hole. And if the delta is small, that means you're seeing sort of the same cluster basically because you have sort of the same values within that UMAP space. All right, so I'm gonna plot my UMAP data against the delta that calculated from the Python script. You plot it next to each other. So you can see that in places where you don't have much variations in the data, in the UMAP, you see it being more of a straight line. And then when you have huge variations, you see a bit more of a spike. So this is something that's quite useful, especially when you're looking at downhole petrophysics data or even downhole assay data. You can use it to find where are the parts down the hole where you see changes in the data. So anyway, that row difference thing is quite a neat thing, and this is something that we're pretty excited about because you cannot do some of these things just programmatically within aiGAS, so a lot of those stuff. Okay, so while we're here and slowly running out of time, so I'm gonna have to hurry up. So we've run through that some of that Python script, and while we're here, I'm just gonna show you a couple of other things that we've added in random forest. Okay, so if I have my clusters here, right, and then I'm gonna select the same variables that I use for my UMAP, I can run a classification tree just to try to understand. So you can use the classification tree to work on the result of a clustering algorithm to try to find out why each cluster is different to one another, and then use that to reuse the classification on a new data set. So that's what classification tree kind of does. But if you hold down your control button on your keyboard and use your mouse wheel, you can now zoom in and out in the classification tree, which in this case is a bit silly because it's quite a small tree. But imagine if it's a large tree, then you can zoom in and out. You can do the same thing in a confusion matrix as well. And this is actually a pretty good example because it's not a small tree, but it's not a big tree as well. But means that you can zoom in and out, and just if it's too small, you can just see the details in here. So we have that change in the classification tree and by also the confusion matrix. You can also bring up a random forest, and the same thing sort of applies. And the thing with 8.3 is that, aside from those changes that we have in the zooming option, which we can now access from the right-hand side toolbar as well, you can zoom in, you can zoom out like that. But you can also save classification tree now. So if I click on this button, I can now save a random forest as an XML. And basically what I'm going to do now is I'm going to show you how to apply that classification tree onto a new row, onto a bunch of new rows. So if I go to the file ribbon now, I'm going to show you another thing that we've added in 8.3. And we can now add new rows into aiGAS. So we've always been able to append new rows into aiGAS, but we can now append to alias columns, and then it will recalculate the derived columns that we already have in the workspace. So as I'm doing that, you can see that it's recalculating all of your ratios. So we've opened up a few diagrams in the past. So we've opened up a Pierce 1996 diagram, which has the ratio of niobium yttrium versus zirconium titanium on it. So it's gonna recalculate those calculated columns on the fly as you append those new rows. But it's not gonna recalculate things that you generate from something that's not parametric, right? So things like UMAP columns and things like that, or a clustering result, it wouldn't know what to do with it, so it's not gonna recalculate it. But with derived columns from a calculation and things like that, yes, it will recalculate the appended columns, the appended rows to those derived columns that you already have in your workspace. And it tells you total result of values calculated based on the appended row. Okay, so what I'm going to do now is I'm just going to minimize everything. And I might just, you might not have known how to do this, but you can actually close off a plot from the list of open windows, where you can right click and close windows from there as well. All right, so if you go to analysis now, if you go to random forest, and I'm just going to remove all of my colors in here, I can actually load a random forest. So that's in the option in here, underneath random forest. I'm just going to select that file. So you can see that the size is quite huge, but that's fine. I think most people will run pretty sizable hard drive these days anyway. So you can open up a random forest, and what it will do is it's going to automatically run it, and it's going to create an output column based on this. So I'm just going to run it on basically every row in the data. And then I'm going to use this to, and let's bring up our 3D attribute map. I'm going to auto attribute based on the random forest that I now run on every hole that I have in this appended data set. So yeah, you can, so previously you can only save a classification tree, but now you can save a random forest. All right, so a couple of other things I want to show you before we finish off. If I start from scratch, so if I don't have any file open in aiGAS, I can import via Python. So that's in the file ribbon. So everything else is grayed out, including the Python script thing in the workflow ribbon, because you don't have a file open. But the import via Python allows you to select a Python script to provide input data into ioGAS. So I have a test script in here to import a last file. And this last file is actually, I think it's from our from one of our tools, the Nova XG tool. It's the downhole gamma tool. And this script basically strips out the headers and all the other stuff in the last file, and it just allows you to bring in the columns that you need. And there you go. So that's what it does. So it just brings in, it just strips out the last file and takes all that you need. And I'm just going to select the variable in here. You're going to select the whole. So it's even created a column called well, which is quite cool. And then yeah, and then you can do all sorts of things with this, right? Once you have it in aiGAS, you can cluster it and you can do whatever you want. But anyway, you can import a last file using this sort of Python script. But the limit is just whatever you want, right? You can set up a Python script to run something like calculative mineralogy on some assay table, or do some data manipulation on your data using some Python script, and then bring that into ioGAS. So do some of that data cleanup in Python, before you bring it into ioGAS. All right, so last thing that I want to show, and if you go to the help ribbon, you wouldn't have this on your computer, by the way, but I have this enabled. There's a certain configuration that you need to enable in ioGAS, but you can enable it if you want. But we have a thing called aiGAS. So it's like the chatbot that basically talks to the ioGAS help file and a bunch of other documentation as well. So say if I wanted to ask you a question, how do I use PCA in ioGAS? So it runs you through what's already in the help file and a few other documentations, and it kind of tells you how to do things sort of step by step, right? And it uses the wonderfulness of our ioGAS help file, and it just uses it to allow you to basically talk to the help file. But it also has a few other things in there as well. So like you can also ask it. So we have a few other documentations in there as well. So I just asked you a question. Can you tell me what analytical methods are best used for titanium and zirconium? And then it tells you, you know, some of the methods that's available to you. And then you can ask it some other questions. Is that, you know, how do I attribute polygon in a diagram in ioGAS? You know, things like that. So, you know, if you're new to ioGAS, you know, this is a great resource. So at the moment, aiGAS is available for internal use, and we're opening it up for external testers for those who are interested. So if you're interested in trying out aiGAS, just let us know, and then we can get you set up. But yeah, we're just looking for feedback on this tool. But it basically allows you to talk to the ioGAS help file and find information about other things as well from within this platform. Okay, so let me just bring up that slide again because we're pretty much almost done. There's a couple of other things in the export that I didn't show. So I'll just show you that in a minute, actually. While we have a couple of minutes to spare. So if you right click and go to the export plot option, we now have the ability to we basically revamped this dialog quite a bit, right? So you can choose your file type from export, choose where you want to export it in, and then you can also save your particular plot window size and whether it's using fixed or scaled symbols and things like that. And then it's just a way of standardizing the way that you export plots out of ioGAS. And of course, the same options that we had in 8.2, so exporting as a batch and export window is still the same. Okay, so we're out of time, but hopefully that should give you sort of enough to as an overview of ioGAS 8.3. So just a bit of a recap. The biggest thing, of course, is the improvements that we've added to the drill hole module and the attribute manager and the Python script launcher functions within ioGAS, and that improve publication capability. So I might talk more about this afternoon. Just talking about the safe export window settings and things like that, but also just improving the way that we attribute data within ioGAS. I think those are the biggest things that we've had in this release. So thanks everyone for tuning in, and I will be around in this afternoon session as well to give a run through. I don't think a lot of people attend both, but yeah, it's basically going to be the same thing. But thank you everyone, and yeah, have a good rest of the day and afternoon or evening, wherever you are. Thanks again.